Hi everyone, sorry about the technical difficulties a few seconds ago. Hopefully you can see the screen that says 2019 Webinar Series and that front presentation slide. This is Eric Yan with EA Engineering. I just wanted to go over some housekeeping items with you before we get started. We are asking that attendees hold their questions until the end of the presentation. Online attendees are in listen-only mode and can ask a question by typing it into the question pane on the GoToWebinar panel, or by clicking on the hand icon located on the tab off to the side of the panel. Once I see that your hand is raised, I can unmute you. All right, we're now going to turn the presentation over to Jeff Lieberfinger.
Welcome everyone to the NAOC 2019 webinar series. I'm Jeff Lieberfinger, today representing the NAOC Technology Committee. Today's webinar topic is the Geometrics MetalMapper 2x2 DAGCAP software update overview. As many of you know, the MetalMapper 2x2 is in the process of being validated as a DAGCAP approved sensor. To achieve this validation, Geometrics was required to update its data acquisition software to satisfy certain DAGCAP validation requirements. Today's webinar will provide an overview of data acquisition using Geometrics MetalMapper 2x2 with an emphasis on the recent software updates. Our presenter today is Nick Odlum from Geometrics, and NAOC and the Technology Committee. We want to thank Nick and Geometrics for speaking to NAOC today on this topic. Nick, the floor is yours.
Okay, thanks Jeff, and thanks to NAOC for having me today. Like Jeff said, today's webinar will be about the MetalMapper 2x2 recent software updates with the emphasis on the features that Geometrics has added to get the instrument validated by DAGCAP as an approved instrument for use on UXO advanced geophysical classification projects. I'm sure everyone in this webinar is familiar with what the MetalMapper 2x2 is. A very brief refresher, it's Geometrics Advanced Geophysical Classification instrument that was based on the Naval Research Laboratory's TEMTADS instrument. The instrument has been used successfully by customers for the last 2.5 years on projects around the country. There are currently 10 instruments owned by 9 different contractors that have been used successfully on UXO projects. The instrument is an extremely sensitive scientific instrument that's used in harsh environments. As you know, low production numbers mean we are always looking for feedback and suggestions from the customers on how to improve both the hardware and the software on the instrument. So over the last 2.5 years, while customers have owned the instrument, we've taken feedback from both the users and the regulators to make improvements, both from a user interface standpoint, but also a regulator standpoint, to make sure that the software conforms to the best practices and best operating procedures. So today's talk will cover the improvements mainly requested by the DAGCAP accreditors, but also some improvements we've made based on feedback from users just to improve their workflows and their data acquisition processes. As all of you are familiar, the DAGCAP is the Department of Defense Advanced Geophysical Classification Accreditation Program, which was implemented a couple years ago in an effort to improve the efficiency of cleaning up munitions by ensuring quality data. Quality data requires quality sensors and quality operating procedures. So Geometrics has worked hard to ensure that both the sensors collect high quality geophysical data, but also that the software has features built in to ensure that the operators follow the correct operating procedures to collect that high quality data. The DAGCAP runs an accreditation process which 12 firms have already gone through and several other firms are planning to go through this year. So clearly there's a lot of interest in both AGC work and making sure that high quality, that the contractors can collect high quality data. AGC software, processing software, has already been validated, so there's several programs that have already been validated by the DAGCAP, but there haven't been any commercially available geophysical sensors yet to be validated. The MetalMapper 2x2 has started this process and hopes to be officially listed as a validated instrument by the end of this month, by the end of May of 2019. To do the process, to go through the validation process, the MetalMapper 2x2 was taken to Aberdeen Proving Grounds this past January, where it went through the testing procedures. The testing procedures are not well publicized, but if your firm has gone through them, then you're familiar with what is involved with the validation testing. As you can see in the photo, this was during one of the polar vortex, very, very cold weather. I believe it was about 10 degrees during the week that the instrument was at Aberdeen. And as many of you know, very cold temperatures and very hot temperatures certainly put strain on sensitive electronic equipment. So it was very promising to see that the MetalMapper 2x2 passed the scoring criteria at Aberdeen. So it passed the main requirement for it to be listed as a validated sensor. But during the course of the testing, there were a few findings and features that DAGCAP requested from the instrument to list it as a fully validated system. So I'll discuss today the recommendations from DAGCAP on these software changes to assist with the user's standard operating procedures. One of the major findings from the Aberdeen testing was that Geometrics needed to change the recommended background interval. So, as many of you know, a background measurement is a measurement of the site without any metallic targets in it, and it's used in the processing workflow to remove the instruments, both the influence of the geology, but also the instrument's self-response. Previously, we had recommended background measurements be taken every 2 hours, but based on the findings at the Aberdeen test, we've updated that. The new recommended background interval is now every 1 hour, every 60 minutes. The background measurements will naturally vary over time and space, which is why both temporal and spatial background measurements are essential for proper data processing. So this is one of the major points of emphasis in the workflow, is that good backgrounds must be taken to ensure that good data can be processed. Additionally, as I mentioned, the temperature was about 10 degrees at the Aberdeen test, and the instrument was being stored in a climate-controlled building around room temperature. And what the testers found was backgrounds taken immediately after the sensor was removed from the room temperature conditions into the very cold conditions. The backgrounds changed over time quite rapidly. So Geometrics has also now made a recommendation to store the sensor form at ambient temperatures or allow acclimation time. So if you're working at a site that is either very warm, say 95 degrees or more, or very cold below freezing, it's recommended that you either allow for about a half an hour of time to let the instrument acclimate to ambient temperature, or you can store the sensor platform, so the cart system, in a temperature that is matches the outdoor temperature, so in a non-climate controlled Connex box or something. So on previous NAOC calls and in other discussions, some people have listed this as background drift, although we Geometrics disagrees a bit with that label, as we want to remind the users that this is not a metrology instrument, and there's no recognized standard for EMI units. So I know a lot of the DAGCAP and accreditation laboratories are used to instruments like a mass balance or thermometer that has a calibrated reference point, but the whole idea of making the background measurements is that becomes your new reference point. So we call it background variation and not background drift. So those are the two major background updates. So every 60 minutes, and then also allowing the instrument to match the outdoor temperature. We've also updated the sensor function test. So for anyone who's not familiar with the actual operation of the instrument, a sensor function test is a measurement that's taken at specified intervals to inform the field crew that the instrument is functioning properly. What the field crew will do is place a standardized item, a metal pipe, on top of the sensor and make a measurement, and the software will give them immediate feedback saying sensor function test passed, go ahead and continue the rest of your acquisition. The idea with the sensor function test being that the field crew doesn't waste a day or a half a day of collecting data with a faulty instrument. The sensor function test is not a replacement measurement for the QC measurements. So those are the instrument verification strip measurements. It's just a simple, quick check for the field crew to give them some confidence that the data they collect will be useful. Previously, customers have seen the sensor function test failing in the field, but then in later data processing, it will pass the actual calculation metrics. So on this new software release, we've updated the math that goes into the sensor function test, and it will both match, it will exactly match the data processing calculation that's used in post-acquisition processing. And it's also less sensitive to the placement of the item. Previously, the item needed to be placed almost exactly in the same position. Now, since the calculation's been relaxed, there's a little bit more leeway. So I think the operators will find it a much less frustrating process to get a passing SFT. And finally, we've updated the metadata on the SFTs to now list both which background was used in the calculation of the passing or failing SFT, but also to list what was the reference SFT file that was that the new SFT was compared to. So the way the SFT calculation works is the measurement that's taken in the field is compared to some reference SFT, and previously the reference SFT that was used was unknown to the processor, so they had to communicate with the field crew. Now that information is going to be stored directly in the file, so the data it'll be clear to the data processor which reference SFT was used by the field operators. So we've made a few updates to the measurement types that are available in the field acquisition software. So there were two measurement types that were never really used in any processing workflow and just led to some confusion on the users on what exactly they meant or what exactly they were used for. So those were the dynamic function test and the dynamic background. So those two measurement types have been removed because they didn't really approximate a realistic measurement in the field. A measurement type called a static background reconnaissance was added. So the idea with the SBR measurement is, as I mentioned previously, having good background measurements is essential for processing MetalMapper data. So an SBR measurement is taken in areas immediately surrounding background locations to give the data processor an extra level of confidence that the background locations that they selected are in fact clean, metal-free backgrounds. So one of the big requests from the DAGCAP testing at Aberdeen was that not all file types could be named in the field because of the way that the files are named using the navigation window. So we've added every single valid measurement type as an option in the navigation screen, and I'll show this on the next window. So, and that included the SFT, which is a sensor function test, or sorry, static function test, SBR, the static background reconnaissance, and DQC, that's the dynamic quality control, so that's a dynamic IVS measurement. I realize it may be a little small on the screen here, but now you can see that there are several different shapes and different lines on in this photo. This is a screenshot of the acquisition software, and so now the user has the ability to select every measurement type on the navigation screen. So this will require the project geophysicist to provide the field crew with a project file that includes every single measurement type that the project geophysicist wants to be measured. So that includes SFT measurements, SBR measurements, DQC, which are again the dynamic IVS. So every single measurement type needs to be included now in the project file. Often the measurements like a SFT, a static function test, are taken in the exact same location as a static background, because of course you want your function test to be in a location that's not influenced by buried metallic objects. So what the operator will need to do is use these display options to hide certain measurements when they're overlain on top of each other. So again, for example, a SFT and an SBG will have the same coordinates in most cases. So the operator will need to click, one of those check marks to remove the SBG so they can see the SFT and select it. And so the DAGCAP requirements do not allow for the changing of file names once they've been collected in the field. In general, I don't want to say that is a hard rule every time, but in general, it's not recommended to be changing file name types. So this update to the software will ensure that the users are able to name each file and each measurement type properly in the field. we've made a few minor user interface changes as well. Made some of the fonts a little larger to help the operators see in the field, and identify the target IDs more easily. And so here we have this dashed line now is going to be one of our dynamic QC lines. The solid line is a dynamic anomaly line, and once they're collected, they will change color to indicate to the operator that they've been collected. Additionally, the operator has the ability to click this done, which will remove completed measurements from the navigation display. So especially if the operator has a project file with several hundred static targets or dozens of dynamic lines, it can help declutter and make it a little bit easier for them to navigate to the correct locations. We've also made some user interface updates. These weren't specifically requested by DAGCAP as a result of the testing at Aberdeen, but they have been requested, perhaps suggested by DAGCAP and also requested by customers. So again, the background reminder interval, we recommend 60 minutes, but the software now allows the user to set that to whatever time they want. And so perhaps in some places with varying geology or changing soil moisture conditions, the project geophysicist would request the field crew to collect backgrounds, say every half an hour, or if they think that 2-hour backgrounds are still acceptable at their particular job site, they can change it to every 120 minutes. So it allows a little bit more flexibility. The target proximity radius is now selectable as well. And what that means is, let me go back to a slide. So the default right now for this target proximity radius is 1.5 meters. And so what that means is the software will restrict the operator to selecting a target only when the cart is within 1.5 meters of that position, that GPS position. And this feature was implemented to help the field crews make sure they're selecting the proper target ID. Because again, the files are named automatically. So if the field operator selects the wrong target ID but collects measurement in a different location, it can just be a little bit of a hassle for the data processor to reconcile what exactly was meant to be measured there. So the default target proximity radius is 1.5 meters. However, that is also selectable. And for example, at a place where the users want to use fiducial markings because GPS is covered by tree canopy, or if they have some other reason to want to be able to select targets that are farther away than 1.5 meters, that's now selectable. We've updated the software to support a few more GPS and RTS position strings. So we do allow for a robotic total station to be used, and new GPSs like Trimble R10. One note is we found that if you're using an R10 to turn off the GLONASS setting, for whatever reason, when the GLONASS is turned on, Trimble inserts an extra character. But we may fix that in the future. But as of right now, if you're using R10, turn off the GLONASS feature. And finally, we've added the ability to change the GPS antenna height listing. So that's used both in the calculation of the UTM position, but also in the display on the navigation screen. And so I'll go through exactly what this means over the next few slides here. So here's a nice sketch of a MetalMapper 2x2. Here we have our GPS, and you can see we're on a slope. So recently this version of the software also improved the IMU calculation, especially at high angles. So previously we would misreport some angles from the IMU, and for those who aren't familiar, IMU is the inertial measurement unit, and that corrects for the attitude of the cart, so the yaw, pitch, and roll. And previously, at very high angles, some of the angles were misreported, but we've updated that calculation. So now, even if you are on a slope steeper than you could realistically push the cart, you'll still get correct angles reported. But in previous versions of the software, the GPS antenna height was fixed at 1.1 meters and was not editable by the user. But we've now updated that to be editable by the user. And the reason that this is important for both the field operator and the processor is because of the UTM position that's reported. So the MetalMapper data files will report the GPS latitude and longitude directly out of the GPS unit or a robotic total station if you're using that. And it will report the raw lat long, so directly out of the GPS string. But it will also report a attitude corrected UTM position. And so the UTMs are calculated using a lookup chart, and the UTM position that's reported is the 000 reference point that's referenced in all of the sensor geometry metadata within the file. So that's shown here by this this kind of red circle. So that's the position that's reported as the UTM position. So and that's also the position that's displayed in the navigation screen. And so if your operators are working at a field site with a lot of topography, you can see that there could be some confusion on what position is actually being reported in the navigation screen. So this offset could be several centimeters, up to perhaps 10 centimeters if it's very steep. And what's shown on the navigation screen is this this position here, so not quite the center of the cart. So you can see how there'd be a little bit of a positional offset in the navigation screen. So what you could do, and this is going to be up to the field crew and the project geophysicist, is if you really want this position here, this position here to be displayed on the navigation screen, you can just set your GPS antenna height to be the height from the ground. But then you'll have to know that the UTM positions reported are not going to be the center of the cart. They're going to be on the ground. And so this is an option that's available. I'm not going to say which is the best operating procedure for you guys, but it's something to keep in mind that on steep slopes, the navigation display will have a little bit of offset. And of course, if you're using the instrument in a skid steer or in a litter carry mode or something, it's just something to keep in mind that the height of the instrument may vary a bit off the ground as well. And then one of the features that was not requested by the DAGCAP specifically, but has been a big request for several years now from the users, is an infield inversion feature. And so we've worked with Acorn SI to implement infield inversion that will, in near real time, perhaps 2 to 3 seconds after collecting a measurement, will display the results of an infield inversion to show the position of a metallic dipole in relationship to the cart. So the infield inversion feature right now will automatically detect the most recent SAM measurement, so that's a static anomaly measurement, and the most recent SBG, static background measurement, in the working directory and run the inversion automatically. And what it will display to the user is a cart. So the cart footprint is shown here in gray. The target position is shown here in blue, and it will also show a coherence level to give the operator some idea of how confident the inversion was, that there's in fact a metallic dipole object underneath the cart. The inversion will not run on any measurement besides an SAM, so it won't run on a SFT or be used in the SFT calculations. Because the inversion is directional. It only outputs proper results with the targets oriented under the cart. When the objects are above the cart, as they are in SFT, it gives invalid results. So there is a directionality built in. And so the idea behind this feature is to help reduce the number of recollects, because one of the requirements for collecting MetalMapper data is that the target is directly beneath the footprint of the cart, and so to make sure that the good data is collected without having to revisit the site, this feature will let the operators know, okay, I'm over the target. I collected a good measurement here. We can move on to the next one. Or you can get something like this, where the target is outside of the footprint, and it will clearly show very simply to the operator that, okay, I need to roll my cart back half a meter and make another measurement, and so that way the operators can do a quick recollect, and they won't have to revisit this particular target again, because they'll make another measurement, hopefully see something like this with the target inside the footprint, and move on to the next one. So this is what will be displayed to the operator, but there's more information that is actually included with the infield inversion. And so we've added this to the metadata as well for SAM measurements, is some information for the processor if they're curious about what the results of the quick infield inversion were. So it will be it is recorded as well, and so these like I said, the operator only really sees this coherence and then the position. Excuse me, but there's also polarizabilities and also kind of the magnitudes and directions of where the infield inversion has placed the metallic dipole. So that will be something that is listed for the processor, but may or may not be used in the processing workflow. I'm not sure if how much it'll really be used, but it's still listed there for if the processor is curious. Finally, we've had some requests from customers to provide a test report with future MetalMapper shipments, both new purchases, repairs, and rentals. And so we've developed kind of a test document that will help with customers and their reporting requirements for DAGCAP and their internal ISO checklists and procedures. And so I realize it's kind of small font to read, but basically what the test report is going to show is that all of the receiver cubes, transmitter coils, cables, batteries, IMU, electronics, software version, everything was tested and passed the factory tests prior to being shipped. So this will help a bit with both our internal quality procedures and but also help with the customer's confidence both in the instrument and for all their documentation requirements as well. So that's something that's be relatively new, but you can have it included with future purchases or rentals or repairs. And finally, the future software support. So this is a big question that a lot of customers have had on the recent NAIOC calls, is how will this infield inversion feature be supported? So what we've negotiated with Acorn is that the infield inversion feature is going to be free to use for this calendar year, so in 2019. And so the current users can see how it works and see if it improves their workflows and their operating procedures. And additionally, 2 years of the support will be included from the time of purchase. So if your firm owns a MetalMapper that was purchased this year or last year, you'll still be able to use the infield inversion for 2 years from the time of purchase, and after that 2 years is run out, or if your firm purchased a MetalMapper in 2017 or 2016, starting in 2020, there'll be an annual fee for the infield inversion. It's not the infield inversion is not a requirement per se. So if your firm finds that the infield inversion feature is not really necessary, you'll still be able to use the MetalMapper, but you won't get the software updates. But it's not gonna, not paying the fee won't make it so you couldn't use a released version of the software. So our thought is that the users will find the infield inversion feature useful and be agreeable to the fee, but we're not gonna brick your MetalMapper if you find that you don't want to pay for the annual fee. So if you, I realize everyone's curious what the fee is going to be, so you'll have to contact Geometrics, and we can send you a quote, because depending on the number of MetalMappers your company owns, the pricing will vary a bit. But it's going to be on the order of several $1,000s per year. And finally, I'll do a little sales plug at the end here. We do have a few MetalMappers available for relatively quick delivery this spring and moving into the summer. So if your firm has a project that you've won recently and you need an instrument, please contact us for an updated quote. And like I said, we could deliver, right now we could deliver relatively quickly within a couple weeks. Our Geometrics does have one lease pool unit, but it's going to be, it looks like it's going to be booked for most of the summer. But if you have a project where you can only justify a lease of an instrument, please contact us anyways, and we could see, depending on how long your rental is, we may add a second unit to our lease pool. And I know Jeff and Exploration Instruments has a rental unit as well, and they may be able to also provide you with an instrument. So now with that, I'll and finally, DAGCAP and the Army Corps are going to be doing a little bit of final testing of the new version of the software in the next few weeks. And additionally, they have some test data that was collected by a few different companies at various temperatures that they want to examine as well. Concurrently, Geometrics, we're wrapping up our documentation for the updated manual, as well as those test reports and some notes about background intervals. So we're concurrently doing that as well. So it looks like this version of the software will be ready to release at the end of this month, at the end of May 2019. And at the same time, we believe that the MetalMapper 2x2 will also be listed as an officially validated instrument by DAGCAP, so it'll be listed on the website and be approved for use on these AGC projects. So with that, I'll open up to any questions.
All right, so if anyone has any questions, please submit them to the questions pane. We do have one question. The question is, if the sensor is stored at the ambient temperature, is there no instrument warm-up time necessary at all? Nick, did you need me to repeat the question?
We don't believe so. I think you'll want to store the tablet and the electronics box in a climate-controlled environment. But the sensor platform itself seemed to be more susceptible. The thing about the what a good operating procedure would be is to have the field crew immediately upon arriving on site plug the batteries into the orange box, the orange electronics box, as they get the GPS set up and as they get the cables plugged in and everything, just so the orange box will have perhaps about 10 minutes of time to kind of bring it up to temperature. So even in cold weather, the electronics themselves generate enough heat that it will usually it will be similar operating temperatures, the orange box itself, whether or not it's cold or warm outside. What the results of the DAGCAP found seemed to suggest that the cart itself was susceptible to the temperature variations.
All right, just going to wait a few more moments to see if anyone has any more questions. All right, we got another question. Question is, it was mentioned that during sensor testing, SPG measurements naturally varied over time and space. Can you quantify how they varied, specifically background measurements collected at different times at the same location? Or can this data be provided?
I believe that the Army Corps or DAGCAP, one of the two organizations, I think they may be similar organizations. John Jackson and his team have a lot of background test data that they're examining, and that's what they're going to be working on perhaps over the next few weeks. I'm not sure how they'll quantify it, again, because the geology, the backgrounds are susceptible to geology, including soil moisture, which does vary over the course of the day. It may be hard to quantify how much of the change in background is related to instrument response, instrument self-response versus an actual response to the geology, but I believe that's something that they may work on. And again, we want to emphasize that it's the removing the backgrounds allows the instrument to measure to be able to classify unexploded ordnance, and that's what the instrument's intended to do. And so it's not a it's not like I mentioned, it's not a mass balance or thermometer where it's calibrated to a defined standard. It's the background. The whole point of taking the background is because the measurements do vary over time and space. So I guess that's a long way to answer. I think DAGCAP may provide some amount of quantifying how the backgrounds vary, but I don't have any hard numbers for you right now.
All right, we got a few more questions that are coming in. The next one is, what is the in-field inversion fee for a company for a single MetalMapper 2x2?
I'll ask that question to the person asking that question to email us, because we're still in the process of finalizing that price, but it's going to be on the order perhaps around $4,000 a year.
Next question is, which AGC sensors are currently validated for use on AGC projects?
I'm not sure if any are, but perhaps someone else on the, I don't know if Jeff can jump in on this one, or.
Yeah, Nick, I'm here. Yeah, so it's my understanding from DAGCAP that the original MetalMapper was grandfathered in as a validated system. The TEMTADS was grandfathered in as a validated system, and the MPV was grandfathered in as a validated system, and the MetalMapper 2x2 is in progress of being validated, and then there's some other sensors, the UltraTem and Optima, that should be going through the validation process sometime this summer. So, but some of the systems were basically grandfathered in.
All right, our next question is the in-field inversion cost per sensor or per company? Parentheses with multiple copies.
Right, that's why, yeah, so it'll be some combination of the two. It'll probably be, if a company has multiple sensors, I think it'll be certainly not, it'll be a little bit cheaper. So we're still trying to kind of price, thinking about the way we're going to implement that.
All right, if there are no more questions, we'll pass it on to Jeff.
Okay, thank you. So thanks, Nick, for the update, and thank you everyone for attending today's webinar. The slides and the YouTube video will be made available sometime next week, put up on the NAOC Technology Committee page. For you that are on that are not NAOC members and want a copy of the YouTube link, just let me know, and I will send a link to you when it's available. I guess the other thing is NAOC is always looking for good topics for webinars. So if you have a good topic or wish to present a webinar, please either contact James Salisbury, the head of the Operations Standards Committee, or myself. Like I said, we're always looking for good webinars for our series. So thank you again, and I hope everybody has a nice day.